Hello, I'm Patty Simpson with Simpson Math. In this video, we're going to evaluate logs. Remember the definition of a logarithm. A logarithm is just looking for the exponent. This log base b of x equals y is equivalent to the base raised to that y power, which is equal to that x, which is in that argument place. We're going to evaluate. So when I have log base 7 of 49, I'm just looking for the exponent. I'm asking myself, 7 to what power gives me 49? Or I could write it, 7 to what power gives me 49? 7 to the second power equals 49. 7 times 7 is 49. So it's equal to 2. Log base 7 of 49 is just a fancy way of saying 2. Log base 3 of 27, I'm asking myself, 3 to what power gives me 27? 3 to what power gives me 27? Well, 3 times 3 is 9, times 3 is 27, so it's to the third power. So log base 3 of 27 is just equal to 3. Log base 6 of 1/6, I'm asking 6 to what power equals 1/6? Well, remember that to reciprocate, the exponent that causes it to do that or has it reciprocate is a negative exponent. So when I see that in the denominator, I'm going to think to myself, I'm going to have a negative answer, a negative exponent. And 6 raised to the first power gives me 6. So log base 6 of 1/6 is just equal to -1. Log base 3 of 1 over the square root of 3. I'm asking myself 3 to what power is equal to 1 over the square root of 3. Again, when I see that it's in the denominator, my base is moved down to the denominator, I know that that must be a negative exponent to move it down into the denominator. Then, what square roots it? What is the exponent that shows square root? Remember that 3 to the 1/2 power is equal to the square root of 3. That denominator is my root, and the top is my power. So in this case, I'm moving it to the bottom, and I'm taking the square root, so the exponent is -1/2. If I raise this to the -1/2, the negative would reciprocate it, and the 1/2 means the square root of that 3. So in each case, my logarithm is just equal to the exponent. Let's practice some more. Here I have log base 4 of 4 cubed. Now there's a couple of ways we could do this. One way we could do it is we could just evaluate this first. We could say 4 times 4 is 16 times 4 is 64. Log base 4 of 64. Well, 4 to what power gives me 64? Well, 4 times 4 is 16 times 4 is 64. So it's to the third power. Another way to do that would be to put it into its exponential form so we could see. If we put that into its exponential form, 4 to what power gives me that argument of 4 to the third, you can see that my exponent has to be equal to that exponent of 3. Either way, when my bases are the same, those exponents are the same. Here my bases were the same, so my exponents were the same. So log base 4 of 4 to the third power is just 3. In this case, log base 5 of 5 to the second power, we could do the same thing. We could say this is log base 5 of 25. 5 to what power gives me 25? Well, that's the second power. I could rearrange it, or I could just say when their bases are the same, their exponents have to be the same. So down here, we recognize that their bases are the same, so therefore their exponents are going to be the same. Another example of this is when I start off in my exponential form. So I'm going to write, instead of starting in my logarithmic form, I'm going to do a few where we start in the exponential form. So for instance, let's start here at 7 raised to the log base 7 of 49. So now this one, I have a base raised to an exponent. It just so happens that this exponent is in logarithmic form. That log base 7 of 49 is just equal to, well, we saw log base 7 of 49 was just equal to 2. So this is really saying 7 to the second power, or 7 squared, which 7 squared equals 49. So 7 raised to the log base 7 of 49 power is equal to 49. Here's another example. How about 3 raised to the log base 3 of 27? Again, we know that log base 3 of 27, we did that earlier, that's just equal to 3. So we could say this is 3 to the third power, which is just equal to 27. So 3 raised to the third power is equal to 27. One more. Let's do 6 raised to the log base 6 of 1/6. Well, we saw earlier that log base 6 of 1/6 is just equal to -1. So really we're saying 6 to the -1, but that's just equal to 1/6. Notice in each of those cases, when my bases are the same, the arguments are the same. Bases are the same, the arguments are the same. So here, when my bases were the same, my exponents were the same. And here, when my bases are the same, the arguments are the same. I could put some nonsensical thing down, like star of log base star to the tree. And I know that when their bases are the same, their arguments are going to be the same. So that's just a special case with those logarithms. Let's continue with a few more. Let's do log base 11 of 11. So again, I'm asking myself, 11 to what power gives me 11? Well, 11 to what power equals 11? That's just the first power. What about here? What if I have log base 7 of 7? 7 to what power gives me 7? That's just the first power. Log base 25 of 25. Again, 25 to what power gives me 25? It's just the first power. So when my base and my argument are the same, that exponent is just going to be 1. So if I have log base, tree of tree, I know my exponent is just going to be equal to 1. So when that base and that argument are the same, it's just equal to 1. One last special case here, and that is if I have log base 6 of 1, I'm just evaluating that. 6 to what power equals 1? Remember that when we raise any non-zero number to the 0 power, it's equal to 1. So here, when I take this base and raise it to the 0 power, it's equal to 1. So if I have log base 8 of 1, 8 to what power gives me 1? That too is going to be equal to 0. So anytime 1 is in my argument, I know my exponent is 0. So log base 25 of 1 is equal to 0. So there's a few special cases of evaluating logs. And remember that when you're evaluating a log, you're just looking for the exponent. Math Made Simple, that's Simpson Math. Thanks for watching.